postsynaptic potential that results from a chemical synapse can be excitatory or inhibitory. This means that the local potential created can either bring the membrane potential closer to or further from the threshold that triggers an action potential. If a neurotransmitter like acetylcholine opens a ligand-gated sodium ion channel, sodium ions will diffuse into the postsynaptic cell. This causes a local potential that depolarizes the membrane, bringing it closer to threshold. Since the postsynaptic membrane is closer to triggering an action potential, the membrane is said to be excited. Therefore, this is called an excitatory postsynaptic potential, or EPSP. If a neurotransmitter like GABA opens ligand-gated chloride channels, chloride will diffuse into the postsynaptic cell. This causes a local potential that hyperpolarizes the membrane, bringing it further from threshold. Since the postsynaptic membrane is less likely to trigger an action potential, the membrane is said to be inhibited. Therefore, this is called an inhibitory postsynaptic potential, or IPSP. One EPSP isn't enough to cause an action potential in the postsynaptic membrane. Therefore, we need the sum of multiple EPSPs to add up to enough depolarization to reach threshold. One way this happens is by multiple EPSPs generated from multiple presynaptic neurons at the same time to the same postsynaptic membrane. This is called spatial summation, meaning in the same space. Another way is for multiple EPSPs to arrive one after the other before the postsynaptic potential can return to resting. Each EPSP piggybacks on the last one until threshold is reached. This is called temporal summation, meaning over time.